Okie dokes. We're going to be on page 25 of the Unit 8 packet. We're going to start off by talking a little bit more, or doing a couple of problems on reflections. And then we're going to talk about distance on the coordinate plane, which is going to be good. All right. So let's start with reflections. So if you remember, a reflection it's kind of like looking in a mirror. Your reflection is kind of like the same distance away from the mirror that you are, just in the opposite direction. So we can reflect across the x and the y axis. And today we're going to do both. All right, let's talk about Ms. Shrine and the map of the school. It says Ms. Shrine is drawing a map of the school. Her room is at -3,4 and the gym is at 3,4. The library is a reflection of 3,4 across the x-axis. This point is reflected across the y-axis to graph the office. What figure is graphed on the map? Okay, well, there's a couple different bits of information here. If you want to go ahead and try this one on your own, kind of go ahead of me, that's fine too. But it says her 2 points they give us is her room and the gym. So we have the room, it's -3,4. Okay, remember side to side first, then up and down. So -3 up 4, that's going to be the room. We'll call that maybe R. Okay. We also have the gym, which I know is in quadrant 1 because they're both positive. The gym is 3, 4. Call that the gym. Okay. So those 2 points, they told us right off the bat. But then it says the library is a reflection of 3,4, which is the gym, across the x-axis. So the library is across the x-axis. Well, here's the x-axis. So we have to go across the x-axis to do the reflection. So again, we don't always draw these arrows. I'm just doing it here to show you what direction we're going because we want to go across x. G is 1, 2, 3, 4 away from the x-axis. So to do the reflection, we're going to be 4 away on the other side. 1, 2, 3, 4. So we call this the library. So I'm going to call that L. And then it says this point is reflected across the y-axis to graph the office. So this point here, the one we just did, is reflected across y to graph the office. So if you want to try that one on your own, go for it. If you want to pause it and then unpause it to see what I get as well. Figure is graphed. All right, so we're going to go across the y-axis. So we're going to go in this direction across y. How far is L from the y-axis? L is 1, 2, 3, so the reflection is also 3. 1, 2, 3, there it is. So that is point O, the office. All right, so it says what figure is graphed? Well, what is this? It's not a square because the side lengths aren't all the same. This side length would be like 6, this would be 8. So this would be called a rectangle. It's quite a school. I mean, this is the map of the school. It's kind of plain, I guess. Rectangle. There's an E in there, or an L, I'm sorry. There we go. All right. Here's another reflection one. Again, if you want to try this one on your own, you can go ahead and pause it and try it. This one's somewhat similar, slightly different. It says use a coordinate plane to graph Jasmine's stone garden. Okay. Graph points -1, -4. I think that's supposed to be point E. So I'm going to put an E here. I think that's missing from the directions. So E is -1, -4, and F is -3.5, 4. So first, we're going to do that. We're going to graph these 2 points, E and F. E is negative, both negative, so it's going to be in quadrant 3. -1, and then down to -4. So over side to side, up and down, that's where the point is found, of course. That would be E. F is -3.5, 4. That being quadrant 2. So we're going side to side to -3.5, which would be right here. and then up 4. 1, 2, 3, 4. That's called point F. All right, so kind of a weird, it kind of would be diagonal if we were to connect them, but then it says, then reflect E across Y and F across X. So we'll do one at a time. E is going to go across the Y-axis. Here's the Y-axis. E is going to go across the Y-axis. Well, we're going to go in this direction, side to side. How far away is E from the Y-axis? 1. It's only 1 away, so we're going to go 1 on the other side. There's the reflection of E right here. Other side of Y, 1 away. We would call that E prime. It's the reflection of E. Point F, so that's E across the Y. Point F across the X. So here's the X-axis. We have to go down to go across the X-axis. F is 1, 2, 3, 4 away. So we're going to do the same thing on the other side. 1, 2, 3, 4. It's kind of in the middle of the grid there. We call that F prime. What is the shape of her stone garden? Well, let's see. So I'm going to take my little ruler here and kind of connect these. This is a very simple connect the dots, if you've ever done a connect the dots. It appears to be a triangle. More specifically, it is a right triangle because it has a right angle right here. But what is the shape of her stone garden? It is a triangle. You know what? Let's be specific. Let's call that what it is, which is a right triangle. Okay, so again, reflections across the axis. Just be careful you know what axis you're going across. All right. This right here always trips some people up. We're not going to actually go through and do this together, but if you want to try this on your own, feel free. This is a little scavenger hunt. Be very careful. There are certain steps in here that are tougher than others. Look carefully at the coordinate plane. There's something about it that's different from ones maybe we've used before, besides that there are pictures all over the place. So just be careful. If you do the scavenger hunt, you can check with me next time in math. I'll happy to look at it, but just try your best if you do decide to do it. All right. Good luck. Good luck. All right, so we're going to go to the next page, page 26, and we're going to talk about distance. Now, what do we know about distance already? Distance is always positive, and we know that from the door. We know that from talking about absolute value. I don't know why I wrote position. We talked about distance with absolute value, number lines, things like that. And when we talked about distance, it was always positive because we used absolute value. And absolute value, again, was the distance to 0. So today I'm going to sort of introduce the idea of distance on the coordinate plane. Next time we're going to kind of get into this a little bit more. But the first question is we have a graph here, or a coordinate plane. We have each of the 4 quadrants. Okay, we have quadrant 1, 2, 3, and 4 going in the C direction, IV, of course, the C direction like that. And this is what information can you get from this graph? Okay, we have Taylor's house and the school. What's some information we can get from here? Well, we know that the school, we can kind of make a ordered pair for each one. We got the school here, and we got Taylor's house. The school is 2, 3. 2, 3, which makes sense. They're both positive. This is in quadrant 1. So you go over 2, up 3. Taylor's house, over 5, up 3. Okay, so we have those bits of information. We also have they're both in quadrant 1. So they're both in the same quadrant. So both in quadrant 1. Remember, we always write quadrants in Roman numerals. So that's some information we can get from the graph. It says, how can we find the distance between the 2 points? Well, one way to do it is pretty much just to count the grid spaces between them. So if we start at the school, let's count them. 1, 2, 3. The distance is 3. Okay? So the one way is to count grid spaces. So if we count grid spaces, the answer is 3 units. There's another way to do it. There's another way to do it. Okay? And I'm gonna show you this way here. What you do is this. Find the distance between them. You can also use absolute value. Okay? What I'm going to do first to use absolute values, I'm just going to stack up the 2 ordered pairs. 2, 3, 5, 3. Now I want you to look carefully at these numbers. Okay? 2 of these numbers have a distance between them of 3. Well, if you look at 3 and 3, those are the same distance. Like 3 and 3, there's no distance between them. So actually, because there's no distance between them, I'm going to cross them off. These 2 numbers, 2 and 5, might help us find the distance. Now our answer is 3. How can we get 3 from 2 and 5? Well, we can subtract them. Now we said here we're going to use absolute value. Here's how we might do it. The absolute value of 5 minus the absolute value of 2. And you're probably thinking like, well, that's the same thing as just 5 minus 2, which is right, because the absolute value, remember, is always positive. And 5 minus 2 is 3. Well, 3 units, I guess. Both of them are 3. Now, you might be thinking like, why would you ever use this? This was such a much easier method to use. Well, you won't always get the coordinate plane to find the distance. So this can be helpful when you don't have the coordinate plane and you only have the ordered pairs. So I wanted to show you that method. All right, let's check out the next example. It says, what information can you get? Well, we have point A and we have point B. So we can find their ordered pairs, I suppose, for each one. A would be -2, 3, side to side, then up and down, is where the point is found. And B would be -2, -4. Now let's check the quadrants. This is quadrant 1. We got 2, 3, and 4. How can we find the distance between them? Well, one method is, again, to count the grid spaces. So let's just count the grid spaces. Let's see their distance. 0, 1, 2, 3, 4, 5, 6, 7. So by counting, it's 7 units, which is the answer. However, we can also use absolute value. That's the other method. So the first thing we'll do, and I like to call it the stack, we'll stack them up. -2, 3, -2, -4. And we're going to look to see how can we get 7 from these numbers. And that might help us show how absolute value would work here. Well, look at which numbers would have a distance of 7 between them. -2 and -2, there's no distance between them. These are the same numbers, so we're just going to cross those off. Let's look at 3 and -4. Well, if we added 3 and 4, we get 7, but this is a negative. But if we use absolute value, that will make it positive. So we're going to take the absolute value of 3, which would be like a bird 3 feet above sea level, and we're going to add it to maybe a fish that's 4 feet below. Okay, and you can kind of see that here. We got a bird 3 feet above, fish 4 feet below. If we add their distances to sea level, we'll get the distance between them. So it'd be 3 plus 4, which would be 7. So look at both examples here. When we used absolute value, we crossed off the number that was the same. But I guess how would we know when to add or subtract? What was different about these examples? Let's see if we can, let's try a couple more to see what happens with a couple more examples. How would we know to add or subtract? So we'll find the distance in 2 ways. Method 1 will be counting. Method 2 will be absolute value. So just by counting, U and V, U and V are 1, 2, 3 units away. So the distance between them is 3 units. Well, let's use absolute value to see how we get 3. First, we need the points. So U, we got V. We'll stack them up. U is 1, negative 3. V is 4, negative 3. 4, negative 3. Well, this kind of seems similar to other ones we've had, where we had 2 numbers that were the same. 3, 3, we crossed them out. Negative 2, we crossed them out. There's no distance between negative 3 and negative 3, so we're going to cross those out. Well, how can we get 4 from 1, or I'm sorry, 3, 3's the answer, from 1 and 4? Well, we can subtract them. What number would go first? It would have to be 4 minus 1. So we'll use absolute value. We'll do absolute value of 4 minus absolute value of 1. 4 minus 1 is 3. Look at that. So we subtracted here. There's something similar then between this example and this example, because we subtracted for this example and we subtracted for this example. I wonder why that is. All right, one more here. We're just going to do one more and then we'll be all set. Let's try one using both methods. We'll use the counting method and the absolute value method. Okay, so we got S and T. Let's count first. So actually, when you count 2, you just got to make sure that these are going up by 1, because if they're going up by 2, you'd have to count by 2. But these are going up by 1, so we'll count by 1s. 1, 2, 3, 4. So 4 units. Let's use absolute value for the next method. So we got S and we got T. Let's stack them up. S is in quadrant 1. We're going to go over 4, up 2. So side to side 4, up 2. And then T would be, all right, let's find T here. So T is over 4, down 2, 4, negative 2. All right. Now, the first thing we did each time was cross out the numbers that were the same. Now, you might be thinking both numbers are the same. However, 2 and negative 2 are not the same number. There's distance between them. There's no distance between 4 and 4. Those are the same number. So we're going to cross those off. Okay. So now we have to use absolute value. We're trying to get to 4. So we'd probably add 2 and 2, and we'll use absolute value to make them both positive. So we'll add these. That's weird that we add some of them and we subtract some of them. I wonder why that is. So absolute value of 2 plus absolute value of negative 2, that's going to be 2 plus 2, which the answer would be 4 again. So let me see if I can show you once. These two here, these two examples we added. We added the absolute values. In the top example, the one with Taylor's house and the school, this example and this example, we subtracted the absolute values. There must be a reason. Maybe we'll talk about that tomorrow. If you can figure it out, let me know tomorrow and we'll talk about it. All right, boys and girls, I will see you soon. Have a great day and enjoy. I hope you enjoyed some coordinate plane stuff. All right, bye-bye.